Hi everyone. Um, so today I'm going to continue with the lesson. You have the notes already, and this is math. In case I'm going to put math 552. So we're going to talk about the integration by part method. And remember, we're talking about integral that we cannot solve. So we're looking about the expansion, okay, asymptotic expansion of the integral to approximate it as some parameters are fixed and some goes to infinity. All right, so basically we are interested in I lambda equal lambda to infinity e to the minus t over t squared dt, and lambda is bigger than 1. So we're gonna do integration by parts. The first part I'm gonna skip because you have the note. That's provided you go the wrong way. So we're gonna go the correct way right away. So we're gonna let u equal to 1 over t squared, and dv is e to the minus t dt. So u is t minus 2, du over dt is minus 2t minus 3, then du is minus 2t minus 3 dt. Okay? All right, so, and v is minus e to the minus t. All right, so this is what we have. So this is equal to u times v. U is 1 over t squared minus e to the minus t, and that's from lambda to infinity. uv minus v du is going to be minus 2 lambda to infinity uv minus v du, and then it's going to be 1 over t cubed e to the minus t dt. Again, we're going to let u equal 1 over t cubed, and dv is e to the minus t. And so this will be, okay, so this is equal to, now remember, if you put infinity, you get 0. So this is going to be 1 over lambda squared e to the minus lambda minus 2 uv. So uv will be minus e to the minus t over t cubed minus v du minus lambda to infinity v du. Okay, so I guess du is minus 3t minus 4 dt. So this is gonna be, and v is minus e to the minus t. So we have minus because they're all minuses. Lambda to infinity uv minus v du. This is the, where is the v? This, and then this is gonna be 3 1 over t4 e to the minus t dt, and this is e to the minus lambda over lambda squared plus 2 e to the minus t over t cubed, and all right, so all right, so this is all right, so I have a minus here. Let's see where the minus comes from. uv minus v du. V is e to the minus t, and du. All right, so this will be plus. So I have a minus here. So this is going to be minus. And then this is going to be plus 6. Again, this is lambda to infinity. All right, so okay, let's get it clear here. So let's do plus 2 e to the minus t over t cubed from lambda to infinity plus 6 lambda to infinity e to the minus t over t4 dt. Now, if you evaluate this, this is e to the minus lambda over lambda squared. And here you put infinity, you're going to get 0, you're going to get minus 2 e to the minus lambda over t cubed. And then you're going to get plus 6 lambda to infinity e to the minus t over t4 dt. All right, so this is what we're going to have. And if you, this one, write as 3 factorial. This one, write as 2 factorial. If we continue one more time, so now you do u equal t minus 4, and dv is e to the minus t. And if you keep doing all that, okay, you can easily show that I lambda equal to e to the minus t over t squared minus 2 factorial e to the minus lambda over lambda cubed plus 3 factorial e to the minus lambda over lambda 4 minus 4 factorial e to the minus lambda over lambda to power 5. And this is going to be minus 1 to n minus 1 n factorial over lambda n plus 1 e to the minus lambda plus minus 1 to the n plus 1 factorial lambda to infinity e to the minus t over t n plus 2 dt. So this is what you're going to have. If you keep going that way, in the same way we did, you have the notes. They're very simple to understand, so I don't want to really swell on it and give you a long video that will not upload. So you notice, let's try to have a control over this here. So here, you know lambda, this is lambda here. Now, lambda is less or equal to t from that, okay? So what does that mean is lambda to the n plus 2 is less or equal to t to the n plus 2. And this is 0, less, okay? And so, and so 1 over n plus 2 bigger or equal to 1 over t n plus 2. So let us take a look at this term, lambda to infinity e to the minus t over t n plus 2 dt. This is less or equal to lambda to infinity e to the minus t over t n plus, lambda n plus 2 dt. This is 1 over lambda n plus 2, lambda to infinity e to the minus t dt. And integrate that, that's going to be minus 1 over lambda n plus 2 e to the minus t from lambda to infinity. Remember, at infinity this is 0, so this is going to be 1 over lambda n plus 2 e to the minus lambda. Alright, so in other words, if you write all this together, okay, so let me, I'm concentrating on this term here. Okay, so all right. So if we look at I lambda, it's going to be equal e to the minus lambda and equal 1 to big N minus 1 to power n minus 1 n factorial over lambda to power n plus 1, and then plus e to the minus lambda big O of 1 over lambda n plus 2. So this is your approximation for the integral I mentioned before. So this is the thing here. So I want you to notice in order that the infinite sum diverges. I'm talking about this. If you let n goes to infinity, that sum diverges. Okay? All right. However, for large n, the error can be made small enough. Okay? So basically, that is the integration by parts method. So, but you have to have the same integral. All right. No, Lily, come here. And of course, by increasing lambda. All right. So that is the first part. Let me take a look at the second part. The second part is, so this is a generalization. So now let's see, we have I lambda equal a to b f of t e to the lambda g of t dt, lambda bigger than 1. Okay, so we're going to assume f is continuous. Okay, and g is sufficiently smooth. G is smooth. That means it has a Taylor series, all right, or Maclaurin series, whatever you're looking at, and has a unique maximum at x equals c in AB. All right, and then we're gonna prove that I lambda is equivalent to f of c e to the lambda g of c, the square root of minus 2 pi over lambda g second of c. And this is for lambda bigger than 1. Okay? So this is, if you have an integral like this, how do you asymptotically approximate it? And this is what you basically do. All right, so let's assume G has a maximum at C. That means G prime of C is 0. Of course, you remember that. Okay. So, all right, so let's write G of T is G of C plus G prime of C over 1 factorial times x minus C times T minus C, sorry, plus G second of C over 2 factorial T minus C squared. And let's only do 2 terms. So this is a G of C plus G second of C over 2 factorial T minus C squared. Why? Because that is 0, because G prime of C is 0. All right? So this is what we're going to replace G with. Okay. So let us replace I lambda equal a to b f of c e to the lambda g of c, okay, e to the, this is the way I want to write it, a g of, no, this is a g of t here, remember. So let me call it the g of t dt, that is a to b f of c e to the lambda g of t. I'm gonna write g of c plus the g second of c over 2 times t minus c squared, and this is dt. Okay, so I replace g of t by it is Taylor series. All right, so now we're gonna try to see how we manipulate this. I'm gonna do substitution, so we're gonna let s equal to, okay, so so let me, before I do that, so this is gonna be f of c e to lambda. Yeah, what? Okay. Honey, I cannot take you out. I can't, okay? Please, let me finish the lecture. Okay, no, Lily, Nancy, come take Lily. I'm gonna call mommy on you, Lily. E to the lambda g second of c over 2 times t minus c squared dt. Okay, so we're gonna let s equal to t minus c the square root of minus lambda g second of c divided by 2. And then you do the necessary things, ds equal to dt times the square root of that. Okay, and then you solve for dt. Dt is ds over the square root of that. All right, so let's see what the integral looks like. Okay, so the integral I lambda is f of c e to the lambda g of c divided by the square root of minus lambda g second of c divided by 2 a to b, and the integrand is gonna be, remember, this is a minus c, b minus c, minus lambda g second of c divided by 2, minus lambda g second of c divided by 2, and this is gonna be e to the minus s squared ds. So you know this is less or equal to all that e to the lambda g of c over the square root of minus lambda g second of c divided by 2 minus infinity to infinity e to the minus s squared ds. Well, we know what this is. That is the square root of pi. And then you get the formula. Okay? So you replace this one by square root of pi. This one, rewrite it a little bit, you get the formula we talked about. All right, so this is the one. Let me do a quick example, then I can call it good for today. I don't want to give you much. So let's do an example. So let's say we have I lambda equals 0 to pi e to the lambda sine t dt. Okay? Well, and here lambda bigger than 1. So basically, so here f of t equal 1, g of t is sine t, which has a maximum at c equal pi over 2. So we know that g of pi over 2 is 1. So the formula tells us, let's see what the formula says. So I lambda is about f of c e to the lambda g of c. So that's going to be pi over 2. Pi over 2 is square root of minus 2 pi over lambda g second of c. All right. So this is going to be 1 times e to the lambda. G pi over 2 is 1. The square root of minus 2 pi over minus lambda sine pi over 2. So that is e to the lambda, the square root of 2 pi over lambda, for lambda being large. Okay? There. So now you should be able to do all your homework that I assigned last time, and the homework are written at the end of page 12. All right, I will next Monday, tomorrow, hopefully I can make another lecture for you tomorrow, and I will send you the notes. And remember, we meet on Tuesday at 5 o'clock. We don't meet on Thursday, we meet on Tuesday. Okay, have a good day, and happy Palm Sunday, by the way. Bye.